Hello, good evening. Today I'm going to be solving week 6 of the problem solution videos, lessons 11 through 14. Sorry for the late submission. I was having difficulties with my iPad and I actually had to replace it. So let's just get into it. Okay, find the slope of the tangent line to the graph 4 minus x multiplied by y squared equals x cubed at point 2, 2. So first, we must find the derivative of the product rule here. So our first derivative, we know that 4 cancels out, negative x turns into negative 1, and y squared turns into 2y. So let's just go ahead and do that. Negative 1 comma y squared plus derivative of that 4 minus x, and we're left with y squared, which is 2y, equals the derivative of x cubed is 3 times x, 3x, and then 3 minus 1, which is 2. Now we must solve by taking all of this and putting it on the other side. Oh, also I forgot to add that this is multiplied by the derivative of x over y. So if we were to take this and put it to the other side, we'll be left with 3x squared plus y squared, and then take this and put it to the other side, would make it over 2 parentheses 4 minus x over y equals the derivative of y over x, or the derivative of x. And now we know that our points are 2, 2. So we can go ahead and plug them in. So 3, 2 squared plus 2 squared over 2. 4 minus 2 is 2 times 2 again. Let's solve. 2 squared is 4. 4 times 3 is 12. 2 squared is 4. 2 times 2 is 4. Times 2 is 8. So we're left with 16 over 8, which equals 2. So that's the slope of the tangent line. All right. Moving on to problem 3 of lesson 12. Find the derivative of f of x equals x squared over x squared plus 4 at the relative minimum of 0, 0. So first we must find the derivative of this problem here by using the quotient rule. So how we do this? First we find the derivative of the numerator, which is 2x. Multiply it by the denominator, which is x squared plus 4. Now use the original numerator. First we must subtract though. Use the original numerator and then multiply it by the derivative of the denominator, which in this case is 2x. And then put it all over the original denominator squared. So now we got to solve this. Let's solve it real quick. 2x times x squared is 2x cubed plus 8x minus 2x cubed over x squared plus 4. And we're left with squared also. 2x cubed minus 2x cubed is 0, so 8x over x squared plus 4 squared. And we don't even have to find the denominator because we know the relative minimum is 0. So no matter what it is, anything times 0 is going to be 0. So 0 is your solution. All right. True or false? The sum of two increasing functions is increasing. So let's go ahead and figure this out. So let's say c of x is equivalent to a of x plus b of x. So since both of these functions are increasing, we can assume that the derivative of both a of x, a prime of x, and b prime of x, we can assume that these are both greater than 0 because they're increasing. Well, since that's the case, then we can also assume that c prime of x is going to continue increasing because there's no way it can go down. So the sum of two increasing functions is increasing. Yes. All right, let's go to determine the open intervals where f of x equals x squared minus x minus 2 and check if it's concave up or down. So in order to know if something concaves up or if it concaves down, it depends on the second derivative. And I'm going to get to that here in a second. So the first derivative of this equation here, is 2x minus 1. The second derivative of this equation is 2. We got the first one by multiplying x squared, so 2 times x, and then subtracting 1 from the exponent. And then there's an invisible 1 here because there always is next to an x, and this in this case is negative, so that's what we're left with. And then since the 2 is in front of the x here on the second derivative, we're left with 2. Now, to know if it concaves up or down, we must determine if f prime of x is greater than or less than 0. In this case, it's greater than 0. So, if it's greater than 0, it concaves up. Like this. And the limits are negative infinity to infinity.